In this video, we are going to use class data to discuss important aspects of data cleaning in this racer experiment. First, we are going to find our group ID that was used by the entire class. This class was a stat class, which was 5140 SP. You see that we have quite a bit of data here, and they played the tutorial level on the tutorial track. Notice, though, that if we type stat, there were a few other students here as well that maybe had mistyped the information. So the first thing I'm going to do is just check to see if those are part of our class. This person, even though they have a very similar group ID, doesn't have any possible player names, and there's no data on the tutorial. So we will go with stats, and we can see that there's a player named Unknown 2020. And we will also use the other stat where most of our group data is. And now if we click under the player ID button, we can see several players had actually played this game. Notice that it's possible for me to just show a box plot of my data and summary statistics. And I could probably run a very quick two-sample t-test, and I get a p-value of 0.04. I could look at residual plots, and they don't really look very good here. But a novice statistician might just look at the p-value and say their significance without thinking much more about the data. However, before we do any kind of final conclusions, it is useful to look at the data in more detail. The first thing I'm going to do is to change the x variable from our variable of interest to player ID. And if I look at this player ID, I can see that some people, for example this one, this Forza 2804, only played one game, the Nightingale car, and was very, very slow with that. There's another person here, SSL, who had a very high finish time, meaning they drove the car slowly, and again only played one time. It might be very reasonable, especially if we're thinking about doing a paired test, to remove a few of these players. We'll remove Forza and maybe this SSL, and notice that there's a few other people who played more than one time. This person played the game 4 times. We could remove that person. We also see there's one more person here, Corona, who only used the Nightingale car as well. Now if we look at the summary statistics, we can see most people have played exactly 2 times, as we are supposed to do in a paired test, randomizing whether you do the Bayes or Nightingale car first. But we see there's a few other people who only played 1 time, and then there's a few people here at the bottom who played more than 2 times. So again, if we go back to our body and show summary statistics, removing a few of these, we have an even number of Bayes and Nightingale cars. If we try and do a paired t-test, it will give us an error saying that we need to have clean data for the paired t-test, meaning that each player can only play exactly 1 time. By selecting the clean data option, the Shiny app tries to find the first 2 cars that a player used under this level and track condition. Notice, for example, Corona no longer shows up here and is no longer in our list to remove. However, our first player, Ajab, had played 4 times, but the software just selected the first 2 games that they played. We may decide that that's not appropriate. It may be reasonable to talk among your teammates to determine if you want to completely remove this player from the experiment, or do we want to keep the first 2 races that this player did, or do we want to keep the second 2 races? So even with this clean data, while we have 2 observations for each player, there are some extreme observations. It may be better, instead of looking at the finish time, to look at the top speed reached. There seems to be much more similar results for this type of question. Would that be a better response variable than the finish time? Would it provide a better measure of which car is faster? Another thing we can look at is time to 30. It's how long did this car take to get to 30 miles per hour? It's a measure of acceleration. If you look at this, you see some really interesting patterns where some people took a really long time to get to 30 miles per hour. It seems to indicate that these people maybe should be dropped from our data set because they possibly didn't start racing their car as soon as they could. Going back to the x-axis of body, which are the two types of cars, we can see there were 23 players, and now they each have an observation for a Bayes car and a Nightingale car. Going back to player ID, we can see that the finish time, there were a few people that took more than 150 seconds to complete the race. The good driver data will remove players who did not stay on the track or who took an extra long time to complete the race. So by selecting good driver data, the maximum finish time in this data set is only 30. Going back to body and showing our summary statistics, we now see that we only have a sample size of 14 players who completed both games in a good amount of time. Now that we have clean data, we can run a two-sample t-test with a much smaller p-value. We can run a paired t-test with an even smaller p-value. We could run a ANOVA, or block design, or a randomization test. Using the paired t-test example, we can check out our residuals, and while there are a few outliers, it is not as extreme as our original case. We may want to look at our data a little more carefully. We could simply download the data or just remove the players as we saw fit, instead of trusting the computer's choice on which variables to remove. Hopefully, you can see by this example that the way you clean your data can have a dramatic effect on the p-values. It's important to remember we shouldn't try to remove data just to improve our p-values, but to really think about what data is representative and try and determine which data is really best to use that tells the most authentic story about which car is truly faster.